Okay, so welcome to all of you. Today we will see the general quadrature formula for the numerical integration. Okay, so for that, let I is equal to a to b f of x dx. Divide the interval ab into n equal sub intervals each of length each of length each of length h such as a is equal to x naught this. Okay, so x naught is equal to xn is equal to x naught plus x. That means this is the interval. So these are the intervals. Okay, x naught, x1 and so on. Okay, so therefore your I will be you can write this what not to xl f of x dx. Okay, so by Newton's forward interpolation formula I is equal to x naught to xn so this is what y naught plus p del y naught plus 1 upon 2 factorial p into p minus 1 del square y naught plus 1 upon 3 factorial p minus 1 p minus 2 del cube y naught plus dot dot dot. Okay, so plus dot dot dot, this is dx. Now this is dx. So here what your x na here your x is what x naught plus ph. Okay, we write this as I is equal to x naught to xn f of x dx. Okay, so now here x is equal to x naught plus ph. Okay, so this implies that dx is equal to h dp. Okay, so we want to integrate this, but this is not a function of x, this is a function of p. We want to change the variable now. Okay, so we'll change the variable in terms of p now. So we have the relation x is equal to x naught plus ph. So therefore dx is equal to h dp. We'll change the limit of the integration also. X is equal to x naught implies that. So when x is equal to x naught, so then this is what x naught get cancelled. So this implies that ph is equal to 0. This implies that p is equal to 0. Okay, so x is equal to xn implies that. So if you put x is equal to xn, then this is what xn minus x naught is ph now. This implies that x minus xn. See this is what xn is equal to x naught plus nh. That means xn minus x naught is nh. So nh is equal to ph. This implies that p is equal to n. That means what, if x is equal to x naught, your p is 0, x is equal to xn, then your p is n. So we'll change this. Okay, we'll change this. So therefore what we get then? So I is equal to integration from 0 to n now. Your x naught, when x naught, your p is 0, when xn is this. Okay, so this is what then y naught plus p del y naught plus 1 upon 2 factorial means 2 p square minus p del square y naught plus 1 upon 6. This is what p cube. This is p cube minus twice. This is what minus 3p. This is minus 3p square plus twice p now. Okay, if you take the product of this one, this will be what p square minus 3p plus 2, and you have to multiply by p del cube y naught plus dot dot dot, and we have to integrate this with h dp. Your dx is what h dp. So now we'll integrate this. So h will be constant. So we'll take the here. So what py naught plus p square upon 2 del y naught plus 1 upon 2 p cube upon 3 minus p square upon 2 del square y naught plus 1 upon 6 p raised to 4 upon 4 minus p cube plus p square, because integration of p is p square upon 2, your 2 get cancelled. Okay, so del cube y naught plus dot dot dot, and this is what 0 to n. Okay, now see each term contain p. So if you put the lower limit, then each term is 0. So only you have to put the upper limit. That means what? Replace p by n only. So only you have to do h. Only here what? N y naught plus n square by 2 del y naught plus 1 upon c n cube by 3 minus n square by 2 del square y naught plus 1 upon c n 6 n raised to 4 upon 4 minus n cube plus n square del cube y naught plus dot dot dot. Okay, so this is your I, that is integration from a to b f of x dx. Okay, so here where a is what? X naught, your b is what? Xn. Okay, so this is called the general quadrature formula for numerical integration. Okay, so this is the formula for the general quadrature formula. So now here what? So we have derived the general quadrature formula here. So now what, if you put n is equal to 1, here, then we will get a trapezoidal rule. Okay, if you put n is equal to 2, we will get a Simpson's-Watson rule for the numerical integration, and if you put n is equal to 3, we will get a Simpson-Thread rule for the numerical integration. In the next session, so we will obtain the trapezoidal rule with the help of the general quadrature formula, Simpson's-Watson rule with the help of the general quadrature formula, and Simpson-Thread rule with the help of the general quadrature formula. Okay, so that we will do in the next session. Okay, now we will stop here. Thank you.